Okay, good day, guys. This is Jim Pytel from Columbia Gorge Community College's Renewable Energy Technology program. This is Digital 1, AET 121. Today we're going to discuss the NOT gate in further detail. Okay, so the NOT gate, the symbol that we've been using thus far is this guy, where A is coming in and it's being inverted to signal X. And our truth table looks like this. Given A is low or a 0, X will come out high. Given A is 1 high, X will come out low or 0. Okay, this is the symbol for a NOT gate. There are other symbols that exist that you may see. That's a NOT. The box symbol for a NOT. Another box symbol. These are symbols which mean that. And like I said, this is the symbol that we're going to use. That's the most common one. Okay, let's talk about pulsed operation. So far we've been using some steady state signals coming in, and as we get into lab 5 we're going to start using digital waveforms. So let's apply a digital waveform to our NOT gate. Okay, given signal A that's coming in right here, and it looks like it's a pulsed waveform where it's high from 0 to 1, low from 1 to 2, high from 2 to 3, and back low from 3 to 4, you would expect the output X to look like this. Like that. So basically, it's low from 0 to 1, high from 1 to 2, low from 2 to 3, and then high from 3 to 4, the exact opposite of A. Now, if we were to display these two signals simultaneously in a timing diagram, it would look like this, whereby signal A is high and X is low, perfectly coinciding with our truth table, high and low. Signal A is low, X is high, A low, X high. Okay, so that's basically the timing diagram of the pulsed operation of a NOT gate. The last thing I want to discuss about NOT gates before we move on to our AND gates is how to express an inverter. How to express this operation using Boolean algebra. So given the fact that A is a signal coming into the inverter and X is coming out, so A is going through our inverter and it's going through X, and this is our inverter here. Basically, it's being changed. How do you represent X? Well, X is not A. So how do we represent that? Not A is a bar. So X is equal to not A. You can also call it bar A. But this symbol right here, this not bar, is a negation. So we can also rewrite this guy right here as not A. So all this is just a means of shorthand. You don't have to write things out using all the logic schematics we've used thus far. We can write things using Boolean algebra, which we'll be getting a lot more familiar with in chapter 4. So that is the Boolean expression for not, is that bar. Okay, we are going to go on to the AND gate. We're going to talk about this guy a little bit more.